See? Red dot. Yeah? Yeah. Alrighty. Now, all of you know everything we are doing today, at least until the very last thing we do. You may not know the very last thing we do. But in 20 years of teaching, the unit on exponents is always the worst unit in grade 10 for test scores. I don't know why, because the question tells you what to do. But for some reason, because there's a lot of little things happening, people screw it up all the time. And it's one of those things where if you make a mistake on the first step of a 10-step question, you screw up the whole question. So it's a pain in the butt unit. It seems easy, but it's always trouble. So even though you know all this stuff, I would do a lot of going over of it till we get to the one new thing. That might not even be new, depending on your grade 9 teacher. Everybody cool? All right, let's go. Powers. This symbol right here, 7 to the third, it means what? What does that mean? Gideon, hit me. 7 times 7 times 7. Now, at least once this semester in this classroom, one of you is going to look at that and tell me the answer is 21. One of you is, no, Emma, somebody will. You know that it's not true, but you will. Just like if I wrote 3 squared, somebody is going to say 6. And it's okay. Somebody is going to do it because it's just automatic. 3, 2, it's multiply. 6. It's okay. It's okay. We don't care. We'll sort it out. Now, in grade 9, all of you dealt with this. And you were probably asked to evaluate it. And when you evaluated it, of course you used your calculator, right? Now to evaluate that in your calculator, you all remember how to do it. You pushed 7, and then you pushed some other button. Everybody's calculator has a different button, so I don't bother writing them all out. I write this symbol, because that's what they use in programming. 3, and then sometimes you had to push equals. And if you do that, of course, you know you got 343. Just to remind you all, if you would be so kind, if you have your calculator handy, refresh your mind as to how your calculator does exponents. So if you have it out, make sure you can use 7, the button, 3, and get 343. This button might be an X with a Y. It might be a Y with an X. It might be an X with a blank. Or it might be this symbol, which is called a caret. Not a Bugs Bunny carrot, but C-A-R-E-T. Everybody can do this, right? Okay. Now, one of the problems that happens in math in grades 2 to 9 is a lot of teachers have cute little stories and fun little pet names for what the math is. Right? They use nicknames, they tell stories. I know one teacher that talks about factoring as breaking a princess out of a castle, which is wonderful because it works. But when you go to university or college or training outside of high school and you have to do some math and you ask, well, how do I break the princess out of that tower? The teacher, the professor, the instructor will look at you and say, what the hell are you talking about? Okay? I don't tell little stories. I don't have cute little names. You know why? Because everything in math has a proper name. And I use the proper name. Because if you go further in math, your instructors are going to use the proper names. Just like I call all of you by your proper names. Right? So, I'm going to remind you of what all these proper names are. In this situation, and I will do this all the time, I will use colors. That red box is going with the base. All right? That's what a base is. Now, in grade 9, base was easy because your teacher said it was the big number, I bet. right? So wonderful, the base is the big number. But unfortunately, in grade 10 and onwards, most often there will not be a number there. So a base is the expression which is repeatedly multiplied. So in this case, the base is 7, so that means it's 7 that we're multiplying. Now here's the problem, and I'm going to write this over here. Also in red, because I'm doing everything about bases in red. Bases are immediately left of exponents, which is the next thing we're going to talk about, which is why I give definition this and this. The exponent is the blue thing, and the exponent is the number of bases we multiply. Which seems very easy and self-explanatory, yes? Until you get to slightly higher level math. And we're going to talk about that on the next page. But for our purposes right now, that's everything you need to know. Now, the whole thing, because when you mix blue and red, you get purple, is the power. A power is a base and an exponent. Even though we read it as base to the exponent power. So this would be 7 to the third. Now, all of you already know this. This is not news to any one of you. But like I say, this unit comes back around. And of course, there are special names for two kinds of powers. What are they? Right.
Cubed and squared.
Right. 7 to the 2 is called squared. 7 to the 3 is called cubed. Nobody else gets a special name. Everything else after that, it's to the 4th, 5th, 6th, 7th, and so on. Everybody cool? All right. Now, knowing what you know and knowing what I have just talked about, try to fill in this table. Hopefully you're all working in pencil so you can erase if you make a mistake. Or if not, do all of your work on the left of each column as much as you can. So if you make a mistake, you have room to fix it up on the right. Okay? You may use your calculators, you may talk to each other, do whatever you need to do, but try to fill in this table. Go. Okay? Are you right? Yeah, everybody in the class has 100% so far. Nice. Who feels they have the second one right? I got a few hands. Are you correct? This is the first one that people screw up. Because a lot of people tell me this is 9. Oh, wait, I missed an exponent. 27. Sorry. Negative 27. A lot of people tell me they screw up right here. They tell me the base is negative 3. Did anybody do that? You don't need to put your hand up. You just know if you did or not. Why is this a 3 and not negative 3? Jazz, read. The negative 3 isn't in brackets. And the base is what is immediately left of the exponent. So because there's no brackets, that 3 is the base. But we cannot forget about that negative, so we have to put it here. So it's negative whatever this answer is. 3 times 3 times 3 is 27, so the answer has to be negative 27. Everybody cool? Now, of course, you don't need those brackets. That's just to show you this. You would actually write this as negative 27. Everybody knows that, right? Okay. Number 3. Now this one, because it has the brackets, the negative is part of the base. So that means the both negatives have to multiply. A negative times a negative is, of course, a positive. Everyone still good? Spectacular. There's the next one. You had to use your calculator for that. I did that in my head. Is that right? It is? Okay. And the next one, again, is that right? Okay. We're all good? Now the next one is the next row that people often screw up. What is the base on the next row? Negative 1. What's the power? No, the exponent is 7. What's the power? The first column. Negative 1, how do we have to write it, Brody? How do we write this? What am I going to write right there?
Oh, it should be the negative 1 in brackets.
The negative 1 has to be in brackets. Why? Because the base has a negative and it repeats. You have to have this bracket. Everybody still cool? We're also rocking 100%? Excellent. You got a free one for the next one because that one's easy. 10 times 10 times 10. This one. Why is that there? You don't know what x is. So can you evaluate it? No. Because evaluate means no exponents. Emma, do you like this shade of green? Excellent. It is important to me. I like my notes to be pleasing to the eyes. And the next one, oh, you can see part of it. Damn. The next one's one everybody screws up too. How do I get a negative there when my base is positive? You got to have a negative out in front, right? No brackets. Or could you have brackets? If I put these brackets here, is the answer still right? Jacqueline. Exactly. This part would be right, but this part would be wrong. Everybody understand? That's where that showing your work comes into play, right? Because if I left this whole line blank, if it was all blank, you could write either of these and get that, couldn't you? But because I told you the base is 2, there can't be brackets. Because the base is only what is immediately left of the exponent. Everybody good? All right. I'll ask that question in a minute. The next row, there's 2 ways you could do it. So I use 2 different shades of green. Light green and dark green. Both of them are acceptable. I could have had 3 squared. 3 is a base, 2, 3 times 3. Or I could have had negative 3. Negative 3 is a base, negative 3 times negative 3 to get positive 9. Everybody cool? Everybody has one of them? Did anybody write both of them? Did anybody write the other one for this 9? Yeah. Nice. You could also, of course, have done 9 and 1. Right? This is the hardest one on the sheet because they're double negatives. Negative, then a negative. So the base is still negative 4, so negative, 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 negative. Right? Shouldn't be a negative there. 5 negatives. Oh, wait, 1, 2, 3, 4, 5. There should be a sixth. Whew, how embarrassing. -4. So that, when there's 6 negatives inside the brackets, is positive, right? Because negative times a negative is positive, times a negative is negative, times a negative is positive, times a negative is negative, times a negative is positive. But, because of this guy right here, I got to have a negative out in front at the end. Did everybody get that one right? All righty. And the last one's super easy. So that was grade 9, yes?
Yeah.
In grade 9, everybody did number bases and number exponents, right? How many of you, and it's not a put down or anything, how many of you did that row? How many of you did variable bases and exponents? Be honest, I need to know. You had a letter as a base. Some of you, but not all of you. Okay. That's the big change between grade 9 and grade 10. In grade 9, you didn't have to do anything with letters. So some teachers didn't do it. Some teachers said, we're so close, we could have a letter here instead of a number. And it's the same thing. Okay? Everyone is good? All right, let's do some review, a little bit more review. Turn the page over to page 13, please. I'm feeling pinky today. Whoa, pinky. I said pinky. There we go. Multiplying powers of the same base. So, if you were in grade 9, you definitely saw this. 3 squared times 3 cubed. And what is the answer? Emma? 3 to the 5th, right? Now, why? Gideon.
If you write it out in the extended form of repeated multiplication, you can see that if you're multiplying 3 to the second by 3 to the third, you're just adding on the 3 to the third. So
Gideon, in 20 years of teaching math, you are the first kid that has said that at this point. Every other kid says, because 2 plus 3 is 5. Is that why the answer is 3 to the 5th, or is that what you do? It's what you do. But the why is what you said. Because this is 3 times 3, isn't it? Times, this is 3 times 3 times 3, which gets me 3 to the 5th. Now, here is something that I don't know why people have trouble with math. Everyone was like, oh, math's so hard. If something happens once in math class, how often does it happen? Gideon? Always. Math doesn't break any rules. Math doesn't get up one morning and decide that it doesn't love you anymore and move out. Math does not kick your dog. Math does not rain when it's supposed to be sunny. Math is always the same. If you learn it once, you know it forever. And yet people still say math is confusing. I guarantee you, there is nothing else in your life that if it happens once will always happen, except math class. So, if that is how it works with numbers, how does it work with letters? Because letters are just versions of numbers, yes? So what if I had x to the a times x to the b? What would be the rule I would write there? X to the what power? A plus b. Whatever those numbers are. Does everybody understand? Yeah? Okay. Please notice that they must have the same base. Everybody cool? All right. Now I'm feeling orange. dividing powers of the same base. So 3 to the 4th divided by 3 to the half, or to the 2. Now, we don't use this symbol very much anymore in high school, right? We almost never use that. That's like grade 3 when you first learn division, yeah? How do we write division in high school? What do we write it as? You can say it, Jasreet. We write it as a fraction, don't we? So this would be 3 to the 4th over 3 squared, yes? And you already know the answer. What is it? 3 to the 2nd. Why? Same reason as multiplication. Up top, in the numerator position, we have 4 3s. In the denominator position, we have 2 3s. What is 3 divided by 3? 1. Now you all say cancel there, don't you? That's what every teacher says, cancel. What does that mean? That means 3 divided by 3 is 1. 1 times 1. That's why we get to cancel, because it's multiplying by 1. It doesn't mean anything. A mistake that a lot of kids make when they hear cancel is they think that becomes 0. Is it 0? No, it's 1. Because if that was 0, I would have 0 times everything else, which would be 0. And we can quite plainly see it's not 0. I have 2 3s left over. 3 squared. So what would be my rule that I would write there? X to the a divided by x to the b is what? A minus b. Easy peasy lemon squeezy, right? It makes sense. Multiplication, division are opposite things. So the shortcut is we would do opposite things. Everybody good? All right. Now the next one. What color am I feeling now? Purple? It's my favorite color. You guys should start making a list of things I say like that, because Christmas is soon. And you should be planning your presents now. Because that way you can take advantage of sales and things. You don't have to last minute shop on like December 18th. Be out in the mall on the last day before school when they're busy. You could get my present in like November when the malls are empty. Just saying. Again, we all know the answer. What is it?
3 to the 9. Wait, is that a 2?
It's a 2 there and a 3 there.
Oh, it's 3 to the 6th.
It is 3 to the 6th.
That was a 3 in the 9.
Why? What is the base here? Wait, Amelia. 3 squared is the base, isn't it? So this is saying I have 3 squared 3 times, right? Which is, of course, 3 times 3 times 3 times 3 times 3 times 3 to get me 3 to the 6th, right? What's the shortcut? The rule that you're supposed to memorize. X to the a, all to the b. What is it, Amelia?
X
A times b. Is everybody good to there? That's all of grade 9, right? Some of you went further, but everybody did this in grade 9, right? Okay, here is where it starts to get a little funky. Don't write this down, just think about it. So if I gave you 3 squared squared, the answer is 3 to the 4th, yes? Just think. A squared squared, what is that? Just think. You've got it in your head, right? What is it? Anybody can say it. You don't have to put your hand up. A to the 4th. Everybody cool? Okay. What is this? 3a squared then. Ursahil. Pardon me?
3a to the fourth.
So I have 3a to the fourth. Anybody else have a guess? Amelia. 3 squared a to the fourth. Would we leave it like that? Jacqueline?
It depends if the question tells you to fully evaluate it or not. If you'd like us to put it in simplest forms, then we will continue because you don't know.
And what would this become? 9a to the fourth. Now, have you ever had a teacher not tell you to put something in simplest form? Really?
Yeah.
You've had teachers that say leave their fractions like that when the answer is obviously 3/4? Really?
Yeah.
Okay. Remember how I said at the beginning of the year that I'm a lot different from a lot of teachers you've had? I'm really different from those teachers. Never, ever, 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 ever stop doing math until it is as easy as you can get it. What is easier, 3 squared or 9? If I owed Braden $9, would I say, hey dude, I owe you 3 squared? Or would I say, hey dude, I owe you $9? Which one is simpler? The 9, right? Always get it as simple as possible. Now, why, because you should have figured it out by now, why is that one right and this one wrong? The 3 is part of the base. So that 2 has to apply to that. Everybody cool? All right. Nice. So that's the first little weird thing that might happen that might trick some people. You didn't need to write it down because we're going to do it a few times. Exponent of 0. 3 to the 0. What's the answer? 1. You've all been taught that in grade 9. Everything to the 0 power is 1, right? You've been taught that. You've heard that a million times. Okay, so what is this answer? What's that answer? Gideon? No. Amelia? -1. But I thought everything to the 0 was 1. Why is this -1? Go ahead. The negative isn't part of the base. What is this one? Simrith. That one is +1. Is everybody cool? Who can tell me why? Jacqueline? That's why this is true. But who can tell me why anything to the 0 power is 1? Or did your teacher just tell you, hey kid, everything to the 0 power is 1? They didn't tell you why?
Yeah, they did.
Why?
I asked why.
You asked why? Okay, why? Don't say because.
I didn't actually get a straight answer.
Remember how I said I'm different from many other teachers? You will always get a straight answer from me. Jasreet, do you know why? You're exactly right. Yep. This is why. 3 squared equals 3 times 3, which equals 9, right? Hey, Furio, how's it going? Did you check in at the office?
I did.
You did? Mm-hmm. Okay. Everybody understands that, yeah? Okay. Well, 3 to the 1 is how many 3s? 1, 3. So the answer is 3, correct? So what math did I do here? I took out a multiplication. So I did division, didn't I? Everyone agrees? 9 divided by 3 is 3. Everybody's cool with that, right? Okay. 2 1, what is the next logical exponent? 0. So if it happens once in math, how often does it happen? Always. So when I drop an exponent, I divide by 3, right? So I'm dropping an exponent, so I divide by 3, don't I? What's 3 divided by 3? 1. Everybody cool? Now, I'll show you another way. 3 squared over 3 squared. Isn't that 3 times 3 over 3 times 3? Isn't 3 over 3 1? And isn't 3 over 3 1? And isn't 1 times 1 1? And isn't the rule here that we do x to the a minus b, which would be 3 to the 2 minus 2, which would be 3 to the 0. Does everybody understand? Now, here's the weird thing. Can I put anything in the middle there? Is there any way I could write 3 to the 0 as repeated multiplication? No. Because how do I do 3 times 3 0 times? Like that. There's nothing there, because what's 0? Nothing. Do you want to know something cool about 0? I don't care if you say no, I'm going to tell you anyway. Until like the year 700, there was no number 0. Nobody invented it. Gideon.
Yeah, that's the reason why so many languages, like around the world, use the word 0, even if the languages are completely disparate. Like
Yep.
Like French, English,
Yep.
German, all use 0, and so do languages across the planet.
Yep.
Like Japanese.
Does anybody know who invented 0?
The French.
Nope. Nope. You would think it was Greek, because they always get this answer, don't they? Who did this in math? It was the Greeks. Who did this? Greek. Who did Greek? But it wasn't. It was an Arabic or Indian mathematician. I can't remember which one. But dude gets no credit. Because he's not Greek. He doesn't have a fun name like Pythagoras. Or Protagoras, who's another one. Or Euclid, who, invented geometry. Yeah, okay, he was only like 2,000 years later than the people who built the pyramids. You don't think there was some geometry in the pyramids? But no, because they're Greek, we say they invented everything.
Yeah, and the sort of Arabic golden age kind of collapsed back then, so a lot of that history was lost with it there.
True. All right. Next one's easy. We're back to an easy one. 2 different bases raised to the same exponent. So in numbers, that would look like this. 3 times 2 squared. Now, in grade 9, what would you do with that 3 and that 2? You'd multiply it and get what? 6 squared, which would get you what? 36, right? Easy peasy, right? But what is really happening is this. That 3 is getting squared, isn't it? So what I really have, that's too thick a blue, is 3 squared. And that 2 is getting squared, isn't it? So I have 2 squared. And it is 3 times 2. What is 3 squared? Don't say 6. 9 times what is 2 squared? And what is 9 times 4? 36. So that's what's happening in numbers. But of course, we're in grade 10 now, so we don't always use numbers. Sometimes we use variables, yes? So you got to be intelligent and think. If it happens once in math, it always happens. So this 2 went to the 3 right there. This 2 went to the 2 right there. So what is x, y to the a? Jacqueline. X, A, Y, A. Now, here is where things start to go a little haywire for kids in exponents. Because now we've done 5 different things, yes? Some of you have seen all of them. Some of you have only seen some of them. But all of you need to remember what I'm about to say. Every single exponent rule applies all the time. You cannot forget about Rule 2 when you are working with Rule 5. Do you understand what I am saying? All the rules apply all the time. It's kind of like addition. You can't forget how to add just because you're in calculus, can you? You got to remember everything. Cool? So, if I gave you this, and this you should write down, 3a squared b cubed all squared, what would that answer be? Jacqueline.
3 cubed, a to the 4, and b to the 6.
Not 3 cubed, because that's a 2.
Sorry.
3 squared, right? Would we leave it as 3 squared?
No, it's simplified.
To what? 9. 9a to the 4th, b to the 6th. Is everybody cool? Everyone's good? Okay. Now I'm going to add a wrinkle. I'm going to divide that by 6ab. So what would happen right here? What would I need to write there? Amelia? What should I write in this box right here?
2
I would write 2a squared there.
No.
No, what would I write here?
Sorry.
It's okay. I divided this by 6ab, right? So I fixed that, so here would get 6ab. Everybody cool? Now, what would I do? Every rule still counts. It's pretty easy to see what to do there and there, right? Isn't that just the second exponent rule written on your page? So what is the answer there? A
to the third.
3, because 4 minus 1, right? Because there's 4 A's up there, A. 1 on the bottom, one of them disappears. 3 A's, right? What is the B answer? To the 5th. What haven't we talked about yet? The 9 and the 6, right? Now, what did I just say? All the math you know applies in grade 10, yes? So what would you do if you were in grade 4 and Mrs. Bad Crumble, your teacher, gave you that fraction?
You just plug into the calculator.
No. We are in grade 10. We do not use our calculator for stuff like that anymore. Eloah. Right. It is 3 over 2. Because we want the simplest answer possible. Everybody understand? Everybody cool? That is your first grade 10 level exponent question. Everybody cool with it? All right. Excellent. Turn the page over. Number 6. Might be new to you, might not. But it's easy to figure out. A fraction base. 3 over 2. Is that a fraction? Sure. To an exponent of 2. You're smart kids. When it was 3 times 2, where did that exponent go? In number 5, where did that exponent go? It went to both of them. So what do you think is going to happen here? It's going to go to both of them. So what do I get? 3,
So that's 9 over 4.
which is 9 over 4. Now, some kids at this spot say, oh, 2 minus 2, 0, it's 1. Don't laugh, Maggie. They do it all the time. Why can I not do that? Why is this 3 squared over 2 squared equals 1 because 2 minus 2 equals 0? Why is this all wrong? Gideon?
Well, because it's in the 3 over 2 is in brackets. So if you go by whatever you put in this, you would actually solve the exponents first.
That's one way to look at it. Another way you could look at it is they're different bases. So this law doesn't apply because 3 and 2 are not the same base. Everybody good? So, as always, I write over here with regular letters, x over y to the a is x to the a over y to the a. The a goes to both. Can we forget about all our other rules? No, we cannot. So what if I gave you this? X squared over y cubed all squared. What would the answer be? Let everybody have a thought about it first, because we're starting to get into grade 10 stuff, right? What would this answer be? Pardeep. X to the 4th, y to the 6th. Absolutely right. Why? Because that is x squared times 2 over y cubed times 2. Because remember, according to exponent law 3, I got to multiply. Is everybody good to there? Everyone? Okay. How many of you in the 9th grade saw this? 3 to the negative 2. Oh, yes. So what's the answer? Muskan? No. It is not negative 9. Amelia? It's a fraction. Which is? Not 6. 9. See, I told you somebody would do it. Okay? Can anybody tell me why? Grishill. Long discussion, long way of saying it, but right. Here is why it works. How many of you remembered this? 3 squared equals 3 times 3 equals 9, right? What's the next logical exponent? 3 to the 1, which is 3, which is 3. What did I do there? I divided by 3, right? So what's the next logical exponent? 0. I can't write anything there, can I? No. And that's 1, so I divided by 3, didn't I? Now, what is the next logical exponent? Negative 1. That would mean 3 is my base, and I'm going to multiply it by itself a negative amount of times. Does that make any sense? No, it's impossible. These cannot exist. But we're smart people. We recognize we divided by 3. So what is logically going to happen here? I'm going to divide by 3, which is 1 over 3. Everybody cool? Okay. So logically, 3 to the negative 2. I can't write that. It makes no sense. So logically, what must go here? I should be dividing by 3, shouldn't I? So that is 1/3 divided by 3, which is 1/3 times, I reciprocate that one, 1/3. 1 times 1 is 1, 3 times 3 is 9. So what goes here? 1/9. Now you should all notice something. 3 squared is 9, but 3 to the negative 2 is 1/9. Everybody see that? What is 3 cubed? 3 times 3 times 3, which is? So automatically, what is 3 to the negative 3? 1/27. Does everyone understand? Negative exponents can't exist, because how could we multiply something by itself negatively? Gideon.
Does that qualify 3 to the negative 1 as an imaginary number?
No.
No, it's the...
Imaginary numbers are square roots of negative numbers.
Yeah, okay. I remember negative numbers as a thing with, what was it called? In science,
I don't know.
When you have a really big thing or a really small thing, you do the exponents times 10.
Yeah, that's that's scientific notation.
Notation, that's what it's called. Yes.
Is everybody cool with this? There's another way to show it. I'll use a different color. Notice I've left half a page of note space here, right? Because this is kind of complicated. This is, what if I gave you this? What does that really mean?
3 times 3 divided by 3 times 3 times 3 times 3.
Correct? Okay. What is our shortcut here when we divide? What do you automatically want to do? According to exponent law 2 on the last page. You want to subtract, right? So this becomes 3 to the negative 2, right? Can negative 2 exist? No. We know that this is 1/9, correct? Well, look at this. What happens with those 3's? That's 1, right? What happens with those 3's? It's 1, right? What's left in the numerator? Not 0. 1 times 1, which is 1, right? What's left in the denominator? 3 times 3, which is 9. Is everybody cool? All right. So now I'm going to give you the toughest question I can give you right now. 3a to the 4th b squared all to the negative 2. Damn, son! Does every rule still apply?
Yes.
Yes, it does. I'll wait a moment, then I'm going to ask somebody to tell me what they did first. Not the answer, just what you did first. Would anybody like to tell me what they did first? Not the answer. Gideon?
I multiplied the exponents inside by the exponent outside.
So you went to this. 3 to the negative 2, a to the negative 8, and b to the negative 4. That's the first thing you did? Okay. Is everybody cool with that? Even if they didn't do it, does everybody understand why Gideon did that? Is it okay? Did he follow one of our rules? There's an exponent outside. He put it to everything inside, right? So we're cool. Is he done? Why is he not done? Because you've got to simplify. Because can negative exponents ever exist? No. So we got to fix this up. What is this really? We just did it 3 times. That is 1/9, right? Okay, what is that now? You're smart young people.
I think I got it.
What?
So it's 1 over a to the a times 3.
1 over a to the, that's an 8.
Times 2. 8 times 2.
No, it's an 8.
Oh,
Because 4 times 2. 1 over a to the 8. And what's this one? Yeah, that blue is not a great color. What is this one?
That's 1 over a b to the b over to the 4.
Right. Is that as simple as we could write it? You would write 3 1s there?
Oh yeah, you're right.
What would you write, Gersil? 1 1. 1 over 9a8b4. Is everybody cool? Yeah? Okay. That is where we stop today. You have 13 minutes left in class. Now listen. All I want you to do is page 15 and 16. That's it. Now listen. There are a couple of ones on 15 and 16 that are tricky, but you have all the tools you need to solve it. See if you can figure it out. Now, there's a couple of things I want to point out because the printing is not so good on your guys's. Look at number 23. Can you see that that is a to the negative 4 times a to the negative 1? Okay. Look at 26. Can you see that that is x to the negative 5 on the top? Okay. Look at 27. 5 is the exponent up top. Negative 5 is the exponent on the bottom. Is that visible? What about 28? It's negative 8 up top and negative 3 on the bottom. All those are visible to everyone? Yeah? Okay. And I think everything on 16 is good. Oh, number 30, that's a times. I don't know why whoever made this worksheet that I stole, I don't know why they used dot for times, like 27 of them, and then decided here to put an X. I don't know why they did it. But it's supposed to be a times. Wait a minute, I do know why they did it. They want it to be an X. Because it's a different base. I figured it out. 10 years I've been using this sheet. I've always said that was times. No, I'm going to make it for you guys because you're so smart. That's an X, not a times. Oh, yeah. All right.